Welcome to Keysight Education Portal. Today, we will be discussing the test coverage test for Keysight x1149. We will start by doing an overview of test coverage. The test coverage reports the details of defect detection classification of nodes down to device pin. The key point of the test coverage feature is its consistency and transparency. The test coverage report includes summary of nodes covered, capacitors tested via .6, connectors tested via CET, nodes coverage which describes which nodes are covered by which test type, and lastly, test coverage classification which states either full, shorts only, opens only, drive only or partial. As shown, this is how the test coverage report looks like. The header will list down the project name, the project path where the ABSP is located, and the date when the report is created. In the summary section, it will state the percentage and total node count summary covered in each category of coverage type. The category of test coverage is meant to be transparent for most of the users, and is easy to comprehend for all users. Full coverage will detect both shorts and opens. Shorts only, as the name implies, detects only shorts. Similarly, opens only will detect only open defects. For a drive only, it is a category whereby there is no connect pins. Special signatures are generated in such a way so that when it is shorted to another boundary scan receiver, a fault can be detected. Partial, as the name implies, will only detect a certain type of shorts. For instance, when a 1.8 volt node is shorted to a 3.3 volt node, it may not detect this short because boundary scan test receiver would receive a high as expected. However, it may detect a short when this 1.8 volt is shorted to ground. This may be due to a pull-up or pull-down type of node. We also list the test actions that each of these nodes are exercised. The best feature of our report is the way it is represented with our coding and reporting scheme. The categories are as follows: node name, connections, test coverage types, and test actions. As part of the test coverage report, it is noted that all boundary scan devices are in bold font. The green indicates full coverage whereas purple indicates short only, open only or drive only coverage. Similarly, we have different color codes for different categories of coverage. For non-boundary scan devices, the fonts are normal and not bold. Let us look at the category of coverage on the first node. We find that both the pins of this connection are fully covered on coverage classification. The first one, being a connection in bold font, implies that it is a boundary scan device pin, and the associated resistor in full coverage category implies that this must be a series resistor connecting to another boundary scan pin. As shown, when we check through the other side of the resistor's interconnect node, our interpretation on the first node is validated. We find that the end of the resistor is fully covered with one of the connections being a boundary scan device. As shown from this reporting scheme, it gives a vivid image of how the circuit would look like. This is the key on why this scheme is chosen for reporting. For a netcom or server design which consists of thousands of nodes, reviewing the test coverage is a laborious task for someone to go through the schematics, tests and BSDL files to relate which device is a boundary scan device and the connection. Instead of taking several days to complete a review, our x1149 test coverage report provides a better user experience as solution for the problem associated with the test coverage review. The first category pertains to the full coverage which detects both shorts and open defect. As shown in this circuit example, we identify that both U1 pin 27 and U2 pin 27 are boundary scan cells which are self-monitoring. Being driven by both drivers U1 pin 27 and U2 pin 27, the node is tested in buswire test. If there is a short to fixed node or net with fixed value, or if shorted to another boundary scan driver or output, the receivers on the node will be able to detect the fault. If there is an open, the receiver on the other end will detect the fault as it does not capture the expected data. With this, we can see that this circuit type can detect both opens and shorts. Hence, it is listed under full coverage. Next, let us review the shorts-only coverage. Here, we can see the node NCU9_37 is a no connect. It is a self-monitoring 1149.1 boundary scan cell. If there is a short on this node, the receivers on the node will be able to detect the fault. However, as it is categorized under short-only coverage, it is unable to detect an open as there is no connection to expected driven value from this pin. Now, let us continue coverage. From here, we can find that U4 pin 46 is an output 1149.1 boundary scan cell, which is going to a connector pin and being tested via CET. If the node is open, the CET test on J9 pin 16 will detect the open fault. It is noted that the primary fault coverage for CET is opens only because CET is a power open test. If the node is shorted to VCC or ground, it will not get any signals on the CET. Hence, it will not reflect a failure. However, if it is shorted to another boundary scan cell, we will be able to see a reading. Thus, by not being able to detect all shorts, this is considered as open-only coverage. Moving on to drive-only coverage, we can see that U2 pin 3 does not have a connection, and is an output 1149.1 boundary scan cell. Being an output cell type, if it is shorted to another boundary scan receiver, only then can a fault be detected. Hence, we classify this under drive-only category as we just have a specific test pattern to identify if there is a short to a boundary scan receiver. We will now discuss and review partial coverage. As shown, we have a fixed node connected to a self-monitoring 1149.1 boundary scan cell. If resistor 35 pin 1 is shorted to another voltage rail, the boundary scan receiver on U1 pin 37 will not be able to detect as there is no change in the detection logic. Only when the resistor is shorted to a ground logic, can the short be detected. Hence, this is under partial coverage. We will now proceed to test coverage software guide. Firstly, start by initiating the configuration of chain. After configuration of chain, generate all the tests. Following that, click on Report, Design for Test and lastly, generate XML or HTML.